Hi everyone, my name is Urvind and today I'm making this video to demonstrate my smart parking system over here in which I have been using the Raspberry Pi and the Arduino through the and communicating both the devices via Bluetooth where my Arduino is connected real timely with the Raspberry Pi using the RF communication which is the Bluetooth. The RF communication means the radio frequency communication, and here you can see this one is the code for the Raspberry Pi over here, and I'll tell what how this smart parking system is designed. And so basically, I have used the concept of PWM and the frequency, and here these are the important libraries. One is the Pi Blues. This one is the PY Blues, and then we have the time for getting the logic of our beeps in the buzzer, and this one is the main Raspberry Pi general purpose input output library. Over here I have used the PCM numbering over here to connect my buzzer and my LED for my PWM in my LED. So I have defined these pin numbers, and basically talking about the main logic over here. I am using the PWM in the LED and how this is working. So first, here you can see the target name is wall sensor because my because in the whenever my Arduino starts, it's I have named it as the wall sensor, and I am using the certain UID. I'm using a certain UID to connect with my Arduino, and coming to my main logic over here, which is the brightness and the frequency and the duration of beeps. So I have used a constraint of 5 centimeter between 100 centimeter. Whenever whenever my car is beyond 100 centimeter, then there is no need for any buzzer or any LED light to blink or buzzer to buzz. And hence, if we get in a distance less than 100 centimeter, and then we'll go just less, and according to that my duty cycle of the LED changes, because initially the duty cycle is 0%, and my LED looks like it is off. But since the distance gets more less, and hence the duty cycle increases, and at the maximum level, which is the 5 centimeter of distance, my duty cycle will get 100%. So that's how I'm using the PWM. It basically behaves like it gives us an analog behavior, but we know that LED is a digital component, and that's how I have used the concept of brightness and the LED PWM over here. The closer the object gets, the brighter the LED gets, and its maximum brightness is at 5 centimeter. Now talking about the buzzer side, this main calculation is for my buzzer. It is similarly mapped for the distance between 5 centimeter and 100 centimeter, and when initially I have kept the frequency of the buzzer as 0 hertz, and if the distance gets more less, and approaches to 5 centimeter, the buzzer gets its maximum frequency, which is the 2500 hertz, and hence there is one more logic, because we have typically observed in many parking systems that whenever we are approaching close to the lesser the distance gets, the more fast the beeps of these the more fast the beeps gets. So here's the concept for the duration of beeps, because if we get more close to the if the object gets more closer, the beep timing decreases significantly, and hence suppose there's a beep time of zero point 0.2 seconds, and then we'll get a beep time of zero point 0.1, and then more closer, and at the least distance, which is the 5 centimeter, we will get the 0.02. So this was my whole Raspberry Pi code, and this the logic I have explained is through the main logic I have already explained, which is embedded in my Raspberry Pi code. And now moving on to the Arduino code as well, which is this one. Let's open in IDE, Arduino IDE. So here's the library Arduino BLE, which is used for establishing the Bluetooth connectivity. So I have set the particular UBLE service as 180D, and this is my UID, which is two-way 57, through which my Raspberry Pi will able to identify that it is genuinely connected with my Arduino. And uh, as I have already told that I have set my Arduino's name as wall sensor, so it will pick that name. My Raspberry Pi will pick this particular name over there, search for that name, and this is my whole logic to get the ultrasonic readings, which are which are at which are this is the main distance, and the duration logic over here on which the distance is calculated at centimeter in centimeter. And I have already told you that I am using the constraint of 5 centimeter and 100 centimeter, and hence I am getting the distance over here from the Arduino. So this was my whole task and my whole functionality of this task. Thank you for watching.